Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Computer and Information Sciences, SOCIS, Certificate Programs, Certificate in Information Technology, CIT-001 Fundamentals of Computer Systems, Block-1 Hardware and Software, and Introduction, Unit-1 Introduction to PC. 1.0 Introduction. Computer is the most powerful tool man has ever created. Computers are used in almost every working place in the modern times, that is school, colleges, offices, railways, banks, industries, hospitals etc. The word computer comes from the word compute, which means to calculate. So a computer can be considered as a calculating device that can perform arithmetic operations at a high speed but more accurately. Computer is a digital electronic storage device, which accepts data and set off instructions, manipulates it, and retrieves the information at very high speed. In other words, we can say that a computer is a data processing device which, following specific instructions, perform a sequence of operations to achieve a desired result. In this unit we will discuss about personal computers, PC, and its components. From here onward, the words PC and computer are used interchangeably. 1.1 Objectives. After going through this unit, you will be able to describe the main components of personal computer, PC. Discuss the role of CPU, CU and ALU. Describe the various types of memory such as RAM, ROM, PROM and EEPROM etc. Define and explain the various types of I/O, input and output, devices, and define the various types of peripheral devices. 1.2 Introduction to PC. Specifically, a computer receives input, data and instructions through the input devices, such as keyboard or mouse, process the data according to the specified instructions and then presents the output, results, in a readable form on its output device, i.e. either on its screen, monitor or on paper through the printer attached to it. A simple analogy can be drawn between the sequence of operations performed by a computer and man to process data. Suppose a student asks a teacher, what happens when 8 is multiplied by 6? He receives the answer 40 from teacher. In the case of computer, this process can be described as follows. The teacher's brain receives the question through his ears, analogous to a computer's input device, processes the question with the help of his brain's information processing and analytical ability, analogous to computer's central processing unit, and give the answer through the mouth, analogous to a computer's output device. Further, just as the teacher can write down the answer on a sheet of paper or blackboard, the computer can also print the answer on a paper through a printer attached to it. From the outside, a computer looks like. Look at the screen. Figure 1. Computer system, or desktop PC. The CPU resides inside a box known as the system unit, along with various support devices and tools for storing information. You can think of the system unit as a container for the CPU. The system unit case can either be short and wide, usually underneath the screen, as in figure 1, or it can be taller and narrow, figure 2, and generally sits below of your desk. Look at the screen. Figure 2. A system unit, a tower case. The most notable things in a desktop PC are the screen, or monitor, keyboard, mouse, etc. However, from an architectural point of view, Figure 3 represents a true picture of a PC. Figure 3. A computer system, an architectural point of view. Here memory, system, bus provides a communication between the system components, the CPU, printers, storage etc. The bus is a cable, which carries signals representing data from one place to another. For example, when data needs to be sent from memory to a printer, it will be sent via the system bus. Personal computers, PCs, are used in almost every working place such as school, colleges, offices, railways, banks, industries, hospitals, art and entertainment etc. The following table illustrates various fields where we are using PCs. Table 1. Area of applications of PC. Fields and uses. Education, developing and publishing course material, drawing pictures, doing research work etc. Business and personal, maintaining daily account, i.e., sales, purchase etc. Communicate with your business partner through email, chat etc. Scientific research work, taking photographs of spaces with The help of computers etc. Healthcare. For scanning any part of our bodies, doctors can search latest research and medicine through computers. Art and entertainment. You can create your own drawing, painting, listening music and watching movies through computers. Every modern computer system consists of three basic sections. Introduction 1. Input device, i.e., keyboard, mouse, scanner etc. 2. Processor, or CPU. Control unit, CU. Arithmetic logic unit, ALU. Memory unit. 3. Output device, visual display unit, monitor, screen, printer etc. Look at the screen. Figure 4. Block diagram of a computer. The basic parts of a computer are shown in Figure 4. Input devices such as keyboard, mouse or scanner are used to enter input, data and instructions directly into the computer. The CPU is like the human brain. It has a memory, and just like there is a faculty in the brain that regulates the functioning of all parts of the body, it has a control unit, CU, which controls the entire operation of a computer including its input and output devices. Processing of data is done in the arithmetic and logic unit, ALU. It performs arithmetic and logic operations such as addition, subtraction, multiplication, and division. Here, the word logic is used because a computer, unlike a calculator, has a capacity to do logical operations also, such as comparing two numbers etc. The function of a computer can be described as follows. The input is released under the direction of control unit, CU, from the input device, say keyboard, to the memory unit. The control unit directs the requisite part of input to be sent to the ALU for being processed. After the processing is over, control unit directs the ALU to release the processed output to the memory. Then, finally, the output is released from the memory to the output device, say monitor, screen. Thus, a computer does mainly the following four functions. 1. Receiving input. Accept information from outside through various input devices, such as keyboard, mouse, etc. 2. Process information. Perform arithmetic and logical operations on the info. 3. Produce output. Communicate information to the outside world through output devices like monitor, printer etc. 4. Store information. Store the information in storage devices like hard disk, pen drive etc. These four functions are responsible for everything that computers do. Components of a computer system are given in Figure 5. Auxiliary storage device floppy, pen drive, CD-ROM. Look at the screen. Figure 5. Components of a computer system. 1.3 Central Processing Unit, CPU. In a human body, the brain takes all major decisions and the other parts of the body function as directed by the brain. Similarly, in order to work a computer, also needs some introduction to PC sort of brain or calculation capacity. In a computer system, there is a device roughly the size of a large postage stamp, known as the Central Processing Unit, CPU. In a computer system, all major calculations and comparisons are made inside the CPU. It is also responsible for activating and controlling the operations of other units of a computer system. The CPU resides inside a box known as the system unit, along with various support devices and tools for storing information. Just think of the system unit as a container for the CPU. The system unit case, that is the metal case itself, usually sits on top of your desk, often underneath the screen, as shown in Figure 1, or it can be taller and narrow, in which case it generally sits underneath your desk and is referred to as a tower case, as shown in Figure 2. CPU reads and executes program instructions, performs calculations, and makes decisions. The CPU is mainly responsible for storing and retrieving information on disks and other media. It also handles information from one part of the computer to another and directs the flow of traffic throughout the computer system. Below you can see meaning of each word of a control processing unit. It is a unit because it is a chip, which consists of transistors. It is called a processor because it does arithmetic and logical operation. It is central because it controls all activities of a system. A block diagram of a modern computer is shown in Figure 6. Look at the screen. Figure 6. A block diagram of a basic computer organization. Basically, the control unit, CU, and the arithmetic logic unit, ALU, of a computer system are jointly known as the central processing unit, CPU. Logically, we can say CPU equals CU plus ALU. Thus, the CPU has mainly two parts: control unit, CU, and arithmetic logic unit, ALU. The control unit, CU, controls the entire operation of a computer. It is responsible of carrying out program instructions and telling the rest of the computer system what to do. It manages and coordinates the entire computer system. It obtains instructions from the program stored in the main memory, interprets the instructions, and issues signals that cause other units of the system to execute them. Although it does not perform any actual processing on the data, the control unit acts as a central nervous system for the other components of the computer. It manages and coordinates the entire computer system. The arithmetic logic unit, ALU, of a computer system is the place where the actual execution of the program instructions takes place during the processing operation. The internal architectural design of computers differs from one system to another. However, the basic organization remains the same for all computer systems. A block diagram of the basic computer organization is shown in Figure 6. Now let us look at each part of CPU in detail. 1.3.1 Control Unit, CU. How does the input device know that it is the time for it to feed data into the storage unit, or memory? How does the ALU know what should be done with the data once those are received? And how the final results are sent to output device, monitor, screen or printer etc., not the intermediate result? All this is possible because of the control unit, CU, of the computer system. By selecting, interpreting and seeing to the execution of the program instructions, the control unit is able to maintain order and direct the operation of the entire system. The control unit, CU, basically does the following things. It manages and coordinates the entire computer system. The CU is responsible of carrying out program instructions and telling the rest of the computer system what to do. It obtains the instructions from the program stored in the main memory, interprets the instructions and issues signals that cause other units of the system to execute them. The instruction register contains a current instruction once it has been fetched from the primary memory. The control unit uses the instruction contained in the instruction register to decide which circuits need to be activated. See Figure 5. Program counter contains the address of the next instruction to be fetched for execution. Figure 5. It communicates with both the arithmetic logic unit and main memory. The control unit coordinates the activities of the other two units as well as all peripheral and auxiliary storage devices linked to the computer. The CU instructs the arithmetic logic unit which arithmetic operations, such as addition, subtraction etc., or logical operation, comparison between two numbers, is to be performed through control logic unit shown in Figure 7. Figure 7, Control Unit. Look at the screen. Specialized electronic circuits, fetch and decode unit, in the control unit is designed to fetch and decode program instructions held in the main memory. Each instruction is read from the memory into the instruction register. The process of reading an instruction is often referred to as the fetch-execute process. 1.3.2 Arithmetic Logic Unit, ALU. The arithmetic logic unit, ALU, of a computer system is the place where the actual execution takes place. All the arithmetic calculations such as addition, subtraction, multiplication, and division are performed and all comparisons, decisions, are made in the ALU. Relational operator, equals, less than, greater than, i.e., equal to, less than and greater than are used to describe the comparison operations by the ALU. ALU carries out arithmetic operations on integer, whole number, and real, with a decimal point, operands. It performs simple logical tests for integers operands only. The data and instructions, stored in the primary memory prior to the processing, are transferred as and when need to the ALU, when processing takes place. No processing is done in the primary storage unit, or memory. Intermediate results generated in the ALU are temporarily transferred back to the primary storage unit until needed at later time. Data may thus move from primary storage to ALU and back again to storage many times before the processing is over. After the completion of processing, the final results, which are stored in the storage unit, are released to an output device, monitor, screen or printer. The accumulator is used to accumulate results. It is the place where the answers of many operations are stored temporarily before being sent to the computer's memory, see figure 6. Only the final result is transmitted to the memory unit for storage. To understand the operation of CU, ALU etc., let us execute the statement. OR command, R equals N1 plus N2. This statement adds two numbers N1 and N2 places the result in a location X, refer the figure 8. Look at the screen. Figure 8, CPU operation to find data and instructions, adding two numbers. 1.4 types of main memory. The data and instructions which are entered into the computer system through input devices, keyboard, mouse etc., have to be stored inside the computer before the actual processing starts. Similarly, after processing, the results produced by the computer must be kept somewhere inside the computer system before being passed on to the output devices, monitor, screen or printer. Thus, the storage unit, primary, main memory, of a computer system is designed to take care of all these needs. The memory unit is the electronic device that holds data and instructions for processing. It consists of binary cells, i.e., 0 or 1 signals, to store the information. Thus, the memory unit that directly communicate with the CPU is called the primary storage or primary memory or main storage or main memory. It basically stores the necessary programs of system software, which are required to execute the user's program. When we load software from floppy disk, pen drive, hard disk or CD-ROM, it is stored in the main memory. There are two types of computer, main memory inside the computer, as shown in figure 9. 1. RAM, random access memory. 2. ROM, read-only memory. Figure 9. Main memory, ROM, non-volatile, and RAM, volatile. Look at the screen. 1.4.1 Random access memory, RAM. Random access memory, RAM, is really the main store and is the place where the program and software we load gets stored. When CPU runs a program, it fetches the program instructions from the RAM and carries them out. Similarly, if the CPU needs to store the final results of calculations, it stores those in RAM. Thus, CPU, can both read data from RAM and write data into the RAM. If your computer has large RAM, you can run larger programs. RAM is known as volatile memory, that is, the stored data are lost if the power goes off. The following figure 10 shows a common RAM chip. Look at the screen. Figure 10, RAM chip, size 128 megabytes. Motherboard is a microcomputer circuit board that contains slots for connecting peripherals like RAM modules, CPU and adapter cards. Motherboards also have electronic circuitry for handling such tasks as I/O signals from those peripheral devices. A motherboard is the backbone of a computer system. The power of a PC highly depends on the peripherals that its motherboard supports. In older days, the first home PCs uses a 64 kilobytes of RAM memory. Today's modern computers need a minimum of 64 megabytes, recommended 128 megabytes or 256 megabytes to run Windows or Linux operating system with latest number of software. A RAM memory chips come in many different sizes ranging from 1 megabyte to 2 gigabytes. 1.4.2 Read-only memory, ROM. A read-only memory, RAM, is one in which information is permanently stored. Computer almost always contains a small amount of read-only memory, RAM. ROM is used for storing special set of instruction, which the computer needs when it start up, boot up. Unlike RAM, the information from ROM can only be read and it is not possible to write fresh information to it. That is, the CPU can only fetch or read instructions from ROM. This is the reason why it is called ROM. When we switch the computer off, the contents of the ROM does not get erased. Therefore, it is non-volatile memory. Thus, a read-only memory, ROM, is one in which information is permanently stored. The following figure shows a relationship between the CPU and main memory, RAM and ROM. Look at the screen. Figure 11. Relationship between the CPU and main memory, RAM and ROM. 1.4.3 Programmable Read-Only Memory, PROM. A variation of ROM chip is a programmable read-only memory, PROM. A PROM is a memory chip on which data can be written only once. ROM chips are supplied by computer manufacturer and it is not possible for user to modify the program stored inside the ROM chip. However, in case of PROM, a user can customize a system by storing own program in a PROM chip. Once a program has been written onto a PROM chip, the recorded information cannot be changed, i.e., the PROM becomes a ROM and it is only possible to read the stored information. PROM is also a non-volatile memory, i.e., the stored information remains even if power is switched off. The basic difference between PROM and a ROM is that a PROM is manufactured as blank memory, whereas a ROM is programmed during the manufacturing process. To write data on a PROM chip, you need a special device called a PROM programmer or a PROM burner. The process of programming a PROM is sometimes called burning the PROM. 1.4.4 Erasable Programmable Read-Only Memory, EEPROM. Once the information is stored in a ROM chip or a PROM chip, it cannot be changed. However, there is another type of memory chip called Erasable Programmable Read-Only Memory, EEPROM, that overcomes this problem. As the name implies, it is possible to erase information stored in an EEPROM chip and the chip can be reprogrammed to store new information by using a special device called a PROM programmer or a PROM burner. The information stored in an EEPROM chip is erased by exposing the chip for some time to ultraviolet light. When an EEPROM chip is in use, information can only be read and the information remains on the chip until it is erased. An EEPROM differs from a PROM in that a PROM can be written to only once and cannot be erased. EEPROMs are widely used in personal computer. They enable the manufacturer to change the contents of the PROM before the computer is actually delivered. This means that bugs can be removed and new versions installed shortly before delivery. 1.5 Secondary, auxiliary, memory devices. External storage, auxiliary storage, i.e., hard disk, floppy disk, CD-ROM, DVD. Zip drive, magnetic tape, provides a place where data can be permanently stored and transferred to and from main memory, RAM. Secondary memory is also known as auxiliary memory or secondary storage. This is a non-volatile type memory. It means the stored data and programs do not get lost, even after the computer is switched off. Unlike RAM, which loses the contents when the computer is turned off, and ROM, to which it is not possible to add anything new, the auxiliary storage devices allows the computer to record information semi-permanently, so it can be used later by the same computer or another computer. Auxiliary storage devices are also useful in transferring data and programs from one computer to another computer. They can also be used as a backup storage, which allows backup the valuable information that you are working on. So even if by some accident if your computer crashes and the data in it is unrecoverable, you can restore it from backups. The most important auxiliary storage devices are hard disk, floppy disk, CD-ROMs, DVD, magnetic tapes, magnetic disks etc. Floppy disk. Portable. Usually the A drive on your computer. Portable disks means that you can carry with you or can be removed them from disk drive A. A standard floppy disk can hold 1.44 megabytes of data. Slower to access than hard disks and has less storage capacity, but they are less expensive and portable. Hard disk, hard drive. Non-portable. The hard drive is the primary device that a computer uses to store information. In most of the computers, partitioning of hard drive is done and each portion is given a separate drive name. For example, a 80 GB hard disk may be partitioned into 4 drives C, D, A and G, each of 20 GB. Most computers have one hard drive located inside the computer case. If a computer has one hard drive, it is called drive C. If a computer has additional hard drives, they are called drives D, A, F, and so on. The hard drive stores the programs on your computer. When you buy a new program, you must first install it onto your hard drive before you can run it. The hard drive is also called the hard disk drive or fixed disk drive. The size of a hard drive is measured in gigabytes. A 20 plus GB hard drive is common for new computers, and the larger the hard drive, the more programs you can store on your computer. A hard disk hard drive is shown in Figure 12. Figure 12, hard disk. Look at the screen. CD-ROM drive. CD-ROM stands for Compact Disk Read-Only Memory. A CD-ROM drive reads information from a compact disk. CD-ROMs are high-capacity storage. And like floppy disks are portable, removable. You cannot write information to a CD-ROM because it is read-only, you can only retrieve information. However, CDRW, CD rewritable, drives are becoming more common. These drives allow you to record data such as music files etc. onto CDRW disks. You can change the data on CDRW disks. When you type a letter in MS Word, as you type it is being stored in RAM. When you save the file, either to your floppy disk or your hard disk, you are saving to auxiliary storage. The next time you open your letter, you are retrieving it from the auxiliary storage into memory. Auxiliary storage is considered both an input and an output device. Magnetic tape. Magnetic tape is a magnetically coated strip of plastic on which data can be encoded. Tapes for computers are very similar to the tapes used to store the music. Storing data on tapes is considerably cheaper than storing data on disks. Tapes also have larger storage capacities, ranging from a few hundred kilobytes to gigabytes. Magnetic tapes are used for taking backup of the large data from computer system. The table on next page summarizes the different types of secondary, auxiliary memory devices. Table 2. Comparison of different storage devices. Look at the screen. 1.6 Input-Output devices. In this section you will get introduced with the various types of I/O devices available for computer systems. The topics discussed here briefly will be taken up in detail in the Unit 3 of this block. The input-output, also known as I/O, devices provide the means of communication between the computer and the outside world. They are also known as peripheral devices because they surround the CPU. Without any input devices, a computer would simply be a display device and not allow users to interact with it, much like a TV. When using a computer, you must send commands to the computer, and data to be processed. Also, data must be returned from the computer to the user. In order to do this, the computer makes use of input and output devices. Input devices, such as keyboard, mouse, joystick etc., are used to enter data into primary storage, or primary memory, or a hardware device that sends information into the CPU. The Table 3 highlights the categories of which the input devices. Table 3. Categories of input devices. Look at the screen. Category and device name. Keying device, keyboard, punch card reader. Pointing devices, mouse, joystick, touchscreen, light pen. Pen-based computing, speech recognizers. Optical character recognizer, optical scanner, barcode reader, magnetic ink character recognition, MICR. Other devices, digital camera, webcam, smart cards, telephone. Output devices. The output generated by a computer can be transmitted to the user via some devices or media. These devices are called output devices. The following are some examples of different types of output devices commonly found on a computer. Monitor, printer, sound card and speakers, video card, plotter. Monitor, or screen, is also called a video display unit, VDU, that displays both input and output data. It consists of CRT, cathode ray tube, technology. It is basically an electronic gun, which shoots, emits a beam of electrons and illuminates the pixels on the screen. There are two broad categories of printers, i.e., impact and non-impact printers. Impact printer uses striking action to press carbons against a paper to create a character. Dot matrix printer and inkjet printer are some examples of impact printer. The term dot matrix refers to the process of placing dots to form an image. The quality of the image is determined by the dots per inch. Inkjet printer forms text and/or images by spraying streams of quick-drying ink on paper. The ink is stored in disposable ink cartridges. Often a separate cartridge is used for each of the major colors. These colors are usually black, red, magenta, green, cyan, and yellow, CYMK. Today, dot matrix printers are not commonly used or found because of the low-quality printouts, when compared to inkjet printers or other later printer technologies. A non-impact printer such as laser printer uses a laser technology to print images on the paper. Laser printers are often used in corporate, school, and other environments that require print jobs to be completed quickly and in large quantities. A sound card, also known as a soundboard or an audio card, is an expansion card or integrated circuit that provides a computer with the ability to produce sound that can be heard by the user. A speaker is basically a hardware device connected to a computer's sound card that outputs sounds generated by the card. Plotter is used in engineering and architectural drawing. It uses a computer-driven pen for creating blacks and white or color graphic images like charts, graphs, etc. 1.7 Peripheral devices. Peripheral devices are used to communicate with the outside world, or hold information over the long period. Peripheral devices may fall into three basic classes. 1. Input devices, mouse, keyboard, trackball, joystick, scanner, digital camera etc. 2. Output devices, display screen, monitor, printer and speaker etc. 3. Mass storage devices, floppy disk, pen drive, hard disk, CD-ROMs etc. The Table 4 shows internal and external devices of any computer system. Look at the screen. 1.8 Summary. The word computer comes from the word compute, which means to calculate. So a computer can be considered as a calculating device that can perform arithmetic operations at a high speed but more accurately. Every computer has the general structure shown in Figure 13. Figure 13, System Bus. Look at the screen. A computer receives input, data and instructions through the input devices, such as keyboard or mouse, process the data according to the specified instructions via CPU, and then presents the output, results, in a readable form on its output device, i.e., either on its screen, monitor or on paper through the printer attached to it. A computer consists of a central processing unit, CPU, memory and various devices which can be categorized as input-output devices. Information is communicated between these separate units by the system's bus. The central processing unit, CPU, performs the actual processing of data. The data it processes is obtained, via the system bus, from the main memory. Results from the CPU are then sent back to main memory via the system bus. In addition to computation, the CPU controls and coordinates the operation of the other major components. The CPU has two main components, namely control unit, CU, and an arithmetic, logic unit, ALU. The control unit controls the fetching of instructions from the main memory and the subsequent execution of these instructions. The control unit also controls the operation of the peripheral devices, keyboard, monitor or printers, etc., and the transfer of information between the units that make up the computer. The arithmetic, logical unit, ALU, carries out arithmetic operations on integer, whole number, and real, with a decimal point, operands. It can also perform simple logical tests for equality and greater than and less than between operand. The memory of the computer is split into main memory and external, secondary, auxiliary, memory. Main memory is fast and limited in capacity. The CPU can only directly access information in main memory. Main memory cannot retain information when the computer is switched off. Main memory consists of a series of numbered locations called bytes. Each byte equals 8 bits. Secondary memory is slow and virtually unlimited in capacity. Information remain in it, even when the computer is switched off.